Okay, so this is 6.1 continued, so maybe it would be smarter to call this at this point 6.1b. So you have a better idea of what's going on here. We can delete the continued part. So that's what we have, 6.1b. So sometimes equations are given in terms of y. In other words, like you have x alone here and you have y mixed in. And you have x alone here and you have y mixed in. So what you need to understand is you need to think about this for a minute and try to think the other direction. So like this is y positive and this is x positive and this is x negative and this is y negative. So if x is equal to 3 minus y squared, that means we have to go from the origin, we have to go up 3 on the x. So instead of going up 3 on the y, we go up 3 on the x, which is right. And now we have negative y squared, so normally that's upside down. So we want this to go towards, we want it to go, instead of going like a normal parabola would look like this, we want it to be upside down. So upside down is going to be, instead of opening to the right, which is positive, instead of opening up and to the right, those are the two options. So opening up is equivalent to opening to the right. Opening down is equivalent to opening to the left. Okay. So I'm just trying to get a ballpark of what this would look like. And I think you can kind of see what I'm doing. I'm 3, 6, 9. I'm trying to give an idea of what this would look like. And I think that this equation, when graphed, looks something of this nature, like this. Okay. Now we got to look at the next one. So we'll do that one in blue. And that's just the, let's see, it's plus 1. So we need to go up 1, which is actually to the right 1 at this point. And then it's a positive slope. So if you kind of turn your head, so you are looking at this, right, and then you turn your head to the right. So you want to, like, rotate your head down to the right. That's how you kind of want to look at the screen. So now I see, and it's a little weird because the y positive is on the wrong side from what you would normally think. So you got to be really careful about this. You could make a table, but you want a slope of 1, I guess, at the end of the day. So you want to be going, let's see, up 1 and over 1. So let's just make a table at this point. So XY chart for this blue one. If we have an x of 2, if we have an x of 3, if we have an x of 0, what is our y? So I guess we'd have to solve out, unfortunately. So if our x is 2, our y is 1. If our x is 3, our y is 2. And if our x is 0, our y must have been negative 1. So we can just plot 2, 1. We can plot 3, 2. And we can plot 0, negative 1. Now we have a better idea of what this looks like. And they want the area of the region in here. They want this area. So they want all of that. So the thing is, instead of our intersections being in terms of x, our intersections now need to be y's. It's going to make it a lot harder if you were ever to try to do this way, top minus bottom this way. You need to do right minus left. So let's talk about a little bit about what that means. So look at our y's, okay? So this is going to be in terms of y, dy, okay? Our top function is our green function, so 3 minus y squared. And our bottom function is this one right here, so negative 1, negative y, minus 1 rather. Let's look at our lowest y value. Our lowest y value is negative 2. Our highest y value is 1. So this is basically what we want to solve. That's the setup. So think about it, see if it makes some sense to you. What's tricky is when you turn your head to the side and you look at the screen, the y positive will be to your left and the y negative will be to your right. The x positive will be up and the x negative will be down. So it's a little bit funky. It doesn't really solve our problem to just spin our head. But now we just integrate that and find the answer. I'm not going to do that in the interest of time because I think you can integrate the red bubble. So the key is really getting the red bubble. Let's talk a little bit about what this means. Like, can we come up with a, oh, this is a graphing utility to find the region. Well, I want to show you one more thing on this page is if you are in real trouble here, this isn't something I love to teach people, but you could swap everything. So you could switch these. You could switch these. If you switch all the x's and the y's, right, you'd have y equals 3 minus x squared, and you'd have y equals x plus 1. I've just switched them. That's all I did. And really you could just solve that problem that they're switched right now. There can be some concerns with that, so we'll talk about that more in the future. It's a cheat. It's not really the right way of doing it, or it's a workaround. So we'll come back to that. For now, just try to do what I was doing. Get it into terms that you can work with. X equals, basically. Okay, so a graphing utility to find the area of a region. Let me pause and see if I have anything for graphing. Alright, so I was able to find this gem here. Probably a little different than what you've seen me use in the past, but should work. Try to make it a little smaller here. See if that goes. Okay, perfect. So you're missing some things. This is an and, I guess, so we're not in terrible shape there. So this will kind of work just like a normal. Doesn't want to power on. Must need batteries, I guess, huh? There it goes. That was funny. So what we want to do is we want to graph this first one. So I'm just going to graph the square root of x. You'll notice that like right here, you'll see right there that it doesn't go past. So e to the xy, e to the this is supposed to be separated out, by the way. E to the x does not go in there. So just be aware that that's the end of it. So we have the square root of x. That's all done. Times e to the x, and that is that first problem. Then they want you to go from y equals 0 to x equals 0. I don't think you really need to do any of that. Let's just zoom 6 and see what we're looking at. So if we're talking about, we'll go back to that, y equals 0, well that's this line right here. If we're talking about x equals 0, well that's this line right here. So it's this. So now let's look at what our graph does for us. And this is what our graph looks like, something of this nature. So let's see if we can zoom that. I don't know, I think it's actually okay. We notice that it kind of starts up a little bit. If we have 0, 0, that's going to be a point on this, I think. So if we look at the red, 0, 0 is going to be a point. 1 is going to be, I don't know exactly where that's going to be, but it's going to be a little higher. It's going to be E, basically, so 2.7, I guess. So 1 will be here, and it just kind of takes off like that, basically. So that's what they basically said. Oh, and they also gave us the boundary x equals 1. So I'm going to give you another boundary here. So you're looking at this tiny little space in here. If you're trying to figure out what you're trying to find the area of, it's the area of this. Okay. So we're going to use the graphing calculator to get us there. And really what that is, well, if we were to write it out, it would be the integral from 0 to 1 of just this, of just x e to the x dx. That's really all we want. And we can call that y1 if we want. So I guess what I would do is I'm going to go to the main page and I'm going to go to Math 9, which will give me my integral. This is the old one, so let's remember this step, okay? So go through this with me. Go to variables right here, go over to y variables, click on function, and then y1. That's that function that we had. So now we're integrating y1, which is this. This is all y1. So we're integrating this. And now they're going to want to know the limits, so that's where, if you have the old calculator, you'll type in 0 from 0 to 1 with x as our variable. And that should work. Oh, okay, so that means we need to have the x here. So 4x from 0 to 1. So you got to write the function, then put the variable you're using, and then from 0 to 1. This should work now, I hope. Yeah, it's taking its time to figure out the answer. And there you go. So we'll always round to 3 decimal places, so 1.256. 1.256 is our answer. So that's that. Let's see how we're doing on time. Okay, try to get through here. So if we were using a graphing calculator to find this, what are we going to need to do? Well, let's just kind of talk through the steps, and then I'm going to have you try it. So what you're going to do is you're going to set f of x equal to g of x with your calculator, right? Or you could set it all, you can find the intersection. So you can graph these and find this point of intersection. And then if you're trying to find the area of R, you're going to integrate from 0 to, I don't know what this number is, so I'll put question mark. You're going to integrate from 0 to question mark. And what graph is on top? G of x. So g of x minus f of x is on bottom, dx. So what you need to do is you need to put this into y1, right? You need to put this into y2, and you basically need to do y2 minus y1. So notice it doesn't have to be f of x minus g of x. It can be g of x minus f of x. You're going to need to find that point of intersection and find the area of R from that. So you try that, and then actually I'll still have you try to find the area of S. So this is basically your job. So also you're going to have to find this point of intersection, which will be question mark 2, and then you're going to be integrating from what to what. Think about that. And what gets subtracted, right? So that's what you need to think about. You need to fill in these things right here. This, this, and this. Fill that all in. And then your graphing calculator should be able to get you there. So type them into y1 and y2, find the intersection points, do the workout, and you should be able to get there. I'll keep the video shorter so that you can go ahead and do the work to find the area of R and then the area of S. So all you're doing is finding this area first, which is that, and then you're finding this area, which is that. Good luck, and I will see you soon in class.